Web applications use many different protocols. However, the most prevalent protocol out there is HTTP. So in this course, I'm actually assuming that you have a basic understanding of internet protocols and their use, but I'm going to deep dive into the components of protocols like HTTP that you will find in pretty much all web applications out there. Now, the HTTP protocol is defined in RFC 2616. Now, I want to actually go over a few quick definitions before we start going over the protocol and all the underlying technologies, right? The first thing is that whenever we refer to an HTTP server, we basically mean a web server, right? So that web server can be serving a website or a regular web page, specific application. It can be also web services like APIs, right? Like RESTful and SOAP APIs, and we're going to cover those later in the course. Also, the other concept that I want to actually refer to and make sure that you have the good taxonomy is whenever we refer to an HTTP client. Now, whenever we talk about an HTTP client, we're actually talking about browsers, proxies, API clients, and any other custom HTTP client programs. Now, HTTP proxies can act both as a server and also as a client, and making actually requests to web servers on behalf of other clients. Now, proxies enable HTTP transfers across firewall capabilities, and they also provide support for caching of HTTP messages and also filtering HTTP requests, right? Now, later in the course, you will learn how to use tools like the Burp Suite and the Zap proxy to intercept communications between your browser and using as a client and the web server that you're actually going to be testing. Say whatever application or web service you will be you will be testing, and basically you use those type of tools to intercept all the transactions, and in some cases actually to modify the transactions to perform different attacks. Now, going back to HTTP, HTTP is an application level protocol in the TCP/IP protocol suite, right, as you probably already know, and it's actually using the underlying transport layer protocol to actually transmit the messages. But there are actually some other protocols that we will cover later that are related to HTTP as well, or to basically web services as a whole. Now, the HTTP protocol uses request response architecture, right? And basically means that an HTTP client program sends an HTTP request message to a server, and then the server will return an HTTP response message, back to the client. Now, the structure of these request and response messages contain message headers, message bodies, and some other components as well, right? So now HTTP is a very simple protocol, which is actually a good thing and also a bad thing, right? So there's some limitations in HTTP, but because of its simplicity, it actually makes it very attractive for many different, implementations. Now, HTTP is considered in most cases as stateless protocol, which actually doesn't rely on a persistent connection for communication to a web server or to a web service, right? Now, an HTTP transaction consists of a single request from a client to a server, followed by a single response from the server going back to the client. And yes, you can actually transfer a lot of data through it, but typically it's actually a very quick transaction if not a lot of data is actually being transferred. HTTP is different than stateful protocols like FTP, SMTP, IMAP, POP, and many others. When a protocol is actually considered to be stateful, sequences of related commands are actually treated as a single interaction. Now, the server must maintain the state of its interaction with the client through the transmission of successive commands, right? And that's actually until the interaction or that session is terminated. Now, a sequence of transmitted and executed commands is often called a session. Now, HTTP is different because each HTTP exchanges consist of a single request and a single response. That's why HTTP clients and servers are actually not required to maintain state between the transmitted commands, that are exchanged within that session. Now, HTTP and other protocols use URLs, right? And you are definitely familiar with URLs since you actually use them every day. However, I want to actually at least explain what are each of the elements of a URL so you can get an understanding of how to actually use them later and potentially abuse them for the purposes of specific attacks. And I would like to actually at least define these parameters and the elements from an offensive security perspective throughout the course. But let's actually go and take a look at an example that I have here, which is actually the art of hacking, an URL from the art of hacking a website, right? Now, let's actually break down the URL to the component parts. The first thing that you have is the scheme. And that's actually the portion of the URL that designates the underlying protocol that is actually going to be used. In this case, it's HTTPS, so secure HTTP, but it can be HTTP, it can be FTP, SMB, and some other ones, right? But in the case of web services, we're actually talking about either HTTP or HTTPS. Now, that is actually, of course, followed by a colon and 2 forward slashes. And in this example, of course, the scheme, as I mentioned, is HTTPS. Then you actually have the host, right, or the IP address of the server. So it can be an IP address, it can be a DNS name or a fully qualified domain name. In this case, the domain name is actually, or the host is theartofhacking.org. You also see subdomains like www.theartofhacking.org or web1, theartofhacking.org. So, of course, you can have subdomains. In this case, of course, it's very simplistic. It's just theartofhacking.org. Then you actually follow that with an optional port. By default, of course, the web servers actually listen on port 80 if it's HTTP and port 443 if it's actually listening to HTTPS. But in this case, actually, we have configured the web server with a different port, and that port is 8123. So that's where you see the artofhacking.org colon 8123. Then you actually have the path, which is the path from the root directory of the server to the desired resource, right? In this case, we see that there's a directory called dir or dir. Now, in reality, web servers may actually use, all kinds of things. May actually use aliasing to point to documents, gateways, services that are actually not explicitly accessible from the server's root directory, depending on the framework like Django or Flask or Ruby on Rails. You actually may have different structures that are not related to a specific file system path, but they're actually related to specific applications, right? Now, you also have URL parameters, right? So that is actually the portion of the URLs that includes, some optional name value pairs, right? We call it URL parameters, right? Just to be simplistic. Now, those are preceded by a semicolon, and that's also depending on the programming language that you actually use, and it comes immediately after the path information. In this example, the URL parameter is ID equals 89. Now, after that, you also can have an optional portion of the URL that continues another, name value pair, which is called a query string, right? And that represents a dynamic parameter associated with a request. Now, these parameters are actually commonly included in links for tracking and context setting purposes, right? They may also be produced from variables in HTML form. So you're actually going to see that later in the course whenever we actually start trying to exploit some input validation in some of these actually forms and some implementations. Now, typically the request or the query string rather is preceded by a question mark, right? And then you may actually have equal signs to separate names and values and ampersands, right, or amp signs to mark the boundaries between the name value pairs and the actual parameters, right? So in this case, the query string is actually called name equals Omar, right? And then you actually have an ampersand of x equals true, right? And then basically in there is including different boundary names and different parameters that may be actually sent to the web service. Now, the URL notation here applies to most protocols, right? It can apply to HTTP, HTTPS, even FTP, right? So, it's a fairly standard, across many different platforms and protocols. Now, you also have other underlying protocols like HTML and CSS, right? Those are, more languages for you to, create applications, websites. The CSS specifically is the look and feel of that website or the actual web service. Now, you also have other things like APIs, right? Like SOAP or RESTful APIs. And with those, you actually have different representations of data like JSON or XML or the web processing service or WPS, which is actually, WPS in this case is not the same as the WPS in wireless networks. Now, in the next lesson, we will go over the details about HTTP requests, also the HTTP responses, and how they're actually structured and why they're actually important and relevant for security.